Hello everyone. In this video, we will see the equivalent circuit of an operational amplifier. Next, we will discuss about the positive and negative feedback on operational amplifiers. And after that, we will see the closed loop and the open loop gain. So, first, let's see the equivalent circuit. So, in the previous lecture, we have seen the diagram of an operational amplifier. Like this triangle is the diagram of an operational amplifier, and here V1 is the input voltage at the non-inverting terminal, and V2 as the input voltage at the inverting terminal. Here V0 is our output, and the plus VCC and minus VCC, these are basically the power supply for this operational amplifier. So for an equivalent circuit, here we have something which we call it as ZI. Here ZI is basically the input impedance, and similarly for the output, right? Here we have Z0. Z0 is basically output impedance, right? And let's say this is our equivalent voltage source, and this is ground, right? And this equivalent voltage source value is basically A times VID, and VID is basically this voltage, VID, and VID is basically V1 minus V2. So in the previous lecture, we have seen that the output voltage in an operational amplifier is basically the A0 times the A0 is basically the gain of the operational amplifier, and the difference between the voltage, that is V1 minus V2. So similarly here V output is equal to A into VID. So this is our equation. So VID is nothing but the V1 minus V2. So this is our volt equivalent circuit for an operational amplifier. So let's see for an ideal operational amplifier. So for an ideal operational amplifier, the ZI, the input impedance value, is near to infinity, and the output impedance value is near to 0. So you can draw the equivalent circuit of this like this. So this is our operational amplifier, and as the value of ZI is near to infinity, so you can remove the this impedance here. So this circuit is basically the open circuit, right? And similarly here the Z0 value is near to infinity, so you can short circuit here. Yeah, and here is our V output, and this is A times VID, right? So this is basically the equivalent circuit of an ideal operational amplifier. Like for an ideal operational amplifier, the ZI value is near to infinity, and the Z0 value is near to 0. Now let's see the feedback loop in operational amplifier. So in the previous video, I discussed about the feedback. What do you mean by feedback here? So feedback is basically some part of the output, you are feeding it back to the input, that we called it as feedback. So if you see here, Vn is our input voltage, and you are feeding back Vf to the input, right? So your Vf, and by the scale of beta, you are feeding it back, right? The V0 by the scale of beta, you are feeding it back. So Vf is basically beta times of V0, right? And you are feeding this Vf to the basically back to the input, and you are getting the by the feedback, you are getting the final voltage as V dash, right here. So V dash here is basically V input plus V final, right? So this is V dash is basically your equivalent voltage after the feedback. And let's say you are applying a gain. Here is your operational amplifier, and the gain of operational amplifier is A. So here V output is basically A times of V dash, right? So here Vf is basically this. So you can substitute this into this equation. So V dash is basically V in plus beta times of V naught. So now let's see what is basically the positive and negative feedback. So if the feedback is positive, means that the input voltage and output voltage both are in phase. Like if the input voltage is like this, like the V in is having a phase of theta, then the V output will be also like this. It will be also like the V output, and both will have the same phase as theta, right? And in the negative feedback loop, if if this is your V input, and then the V output will be like this, V output, right? And here the phase between the V input and V output is 180 degree. If this is theta, then this will be theta, right? So that we called it as positive feedback and negative feedback. And as you can see, uh, if the feedback is positive, then the V output will be get add up in the V input, and if the feedback is negative, then the V output will get subtracted from the V input, right? So that was positive feedback and negative feedback. Now let's see what is closed loop and open loop gain. So when you purchase an operational amplifier, some A0 value is given there, right? On the IC, you can see the gain is something mentioned for any operational IC, right? So when you purchase from the market, the value which is mentioned on the operational amplifier, that is the A0, is basically the open loop gain. So A0 basically A0 open loop, that we called it. When you purchase from the market, you get this value of A0, and the A0 value is near to the power of 10 to the power 5 for an IC741. And what we called it as the closed loop gain. The closed loop gain is basically A of closed loop is basically the ratio of the V output and the V input, right? And in closed loop, basically, why we called it as closed loop? In closed loop, basically, you feedback the voltage, right? Feedback the output voltage, V output to the input, right? And in this case, you have the gain as ACL is basically gain in the closed loop. It is V output and V input. So that is it. Thank you.